Today, I would like you to imagine that you are in a tough spot. What if the reciprocal key and almost all the keys on your calculator is busted? With only access to the 6 basic trigonometric keys, namely sine, cosine, tangent, and their inverses, could you replicate the function of the reciprocal key on the calculator? That is, if you currently see a display of 5 on the calculator, could you somehow, through pressing only the 6 keys above, make 1/5 show up on the calculator display? This is actually a real math problem given to beginning students in trigonometry, believe it or not. Without further ado, let's take a look at it. Since we are dealing with trigonometric function and all, maybe it would be a good idea to start out from a diagram of a right angle triangle. And here, I will start out with a general A and try to obtain 1/A. A really could be positive or negative here, depending on the direction you designate. As you can see in the diagram, the line extends upwards, so A is positive in our case. I will leave the case where A is negative, so you could have a go at it yourself later. We let one of the side lengths of the triangle be A, and since we want to get 1/A, it makes sense to let the other side length be 1. The hypotenuse would then be square root of A squared plus 1, obtained through the Pythagoras theorem. Note that we let the other side length, which is not the hypotenuse, be 1, instead of letting the hypotenuse be 1. Here, we need to allow the hypotenuse to change according to the value of A, since if not, there would be a constraint on the values of A in order for the square root to be positive. We definitely don't want this, as A shouldn't be constrained. It could really be any real number. With all the side lengths, let's label one of the angle as x. This allows us to obtain the relations for sine x, cosine x, and tangent x. We need to somehow obtain 1/A, and from the triangle, this seems to be achievable by doing tangent of 90 degree minus x. So at least now we know the direction we are working in. Since we do not have access to the square root key, we could essentially only start from tangent x equals A, since this expression only has A in it. The only thing which we could logically do next is to take the tangent inverse of A to get the angle x. From here, given an angle and the trigonometric functions sine, cosine, and tangent to work with, we actually have 2 choices. Well, 3 technically, but it doesn't make sense to take tangent, as this will just bring us back to the starting point. However, taking sine and cosine both seems workable. Let's try both this, first with sine x and secondly with cosine x. Bear in mind that we are trying to get the angle 90 minus x, because its tangent would then be equal 1/A. Here, after taking sine x, you can see that the 2 side lengths which are involved in the ratio are highlighted in green. Is there a way to somehow incorporate these 2 side lengths in a trigonometric function to get the angle 90 minus x? Well, basically, we only have 3 choices. Either sine inverse, cosine inverse, or tangent inverse. Tangent inverse doesn't make sense here, as the hypotenuse is involved, and sine inverse will just bring us back to the starting point, the angle x. However, taking cosine inverse here will actually give us the angle 90 minus x, which is what we wanted. And for the other case, where we initially did cosine x, we can take inverse of sine x to get the same angle 90 minus x as well. Anyway, finally, we could apply tangent to 90 minus x, and this allows us to get 1/A, as we have wanted at the beginning. I sincerely hope you will not be facing this problem on your calculator anytime soon, although I guess it feels good to know that the reciprocal key is just 4 keystrokes away, granted your trigonometric keys somehow still work. We have come to the end of the video. I hope you have enjoyed this fun question. Please give us a thumbs up and subscribe for more content, and I will see you in the next video. Until then, bye.